Today we're going to look at the Born-Haber process in determining lattice enthalpy of an ionic solid. So what lattice enthalpy or lattice energy is the energy change associated with the formation of 1 mole of an ionic compound from its component gaseous ions. So we'll take a look at the formation of sodium fluoride as our example, and the formation reaction for sodium fluoride is sodium is a solid because it's the elements at their standard states, plus 1/2 a mole of fluorine gas, forming 1 mole of sodium fluoride as a solid ionic compound. So we can look up the information of the heat of formation and measure that directly to get that. You can either get that from a table or you could do it experimentally in a lab. So in order to determine the lattice energy, which we can't measure directly, we have to you basically use Hess's law and figure out the energies of a bunch of different processes and kind of do some math to add them up to get our lattice energy. So the first thing that has to happen, since it's formation of an ionic compound from its gas ions, sodium has to go from a solid to a gas. So that, in order for that to happen, you have to add energy, and that's the sublimation process to get the sodium gas. Then you would have to convert the sodium elemental gas to an ion. So that requires the ionization energy to be input to remove an electron from the sodium and make it sodium ion. Fluorine, since it's a molecule, first thing you have to do is get it into atoms. So you would, since you have 1/2 a mole of it, you look up the bond energy for F2, and you would multiply that by 1/2, and that would get the fluorine molecules to the fluorine gas atoms. And then, since it's gaining an electron, it has to have the electron affinity added, which is the energy change associated with the adding of an electron to a gaseous atom. So then you have your gaseous ions, and the energy released during the process of the formation of the ionic solid from the gaseous ions is our lattice energy. So, in sum, the heat of formation of this, the overall reaction, is going to be equal to the components that make it up, the sum of the components that make it up. So you have the sublimation of sodium, the ionization energy of sodium, half the bond energy of F2, and again, the 1/2 is there because it's 1/2 a mole, plus the electron affinity of fluorine, plus the lattice energy. So if you're given all of these but lattice energy, you can then calculate the lattice energy. Or if I gave you the lattice energy, you could calculate the heat of formation. If you have all but one of the variables, you can always solve for the other.